So in this video, we'll look at integration by substitution. And as an example, as the first one, we'll integrate cosine of 3x. And this substitution method conceptually is quite similar to what you learned in chain rule. Usually, in the chain rule problem, you are actually substituting some function, let's call it v, as a function of x into the original function. So in that case, you can simplify the calculation by a lot. And the u substitution method is actually the same. You can see what happens if I let u be 3x. If u is 3x, if u is 3x, I put it here, and same as the chain rule problem, you have to write the derivative naturally as the second step. And the way I write it is slightly different for the integration topics. I write the derivative as du. d equals, you have to tell me the derivative of 3x, which is 3. And the dx, you have to write it on the right-hand side. Basically, please don't be confused about my notation. I mean, essentially, you are finding the derivative only. The du dx at the left-hand side, which is derivative, is the same as 3. So I just pull the dx term into the right-hand side. That's more convenient for us to deal with the current problem here. Now you see the fact is that if you let 3x be u, it's kind of like you are integrating cosine u, but not quite yet, because to integrate the variable u, I have to change it to something to do. Based on the second line here, you have to change. And please look at how you can change this. Based on the second equation here, the fact is dx equals du over 3, right? And so the second line is that you are integrating cosine u, and dx becomes du over 3. And the 1 over 3 is constant, so we can pull it out. Because for constant, it doesn't matter, it doesn't change our calculation much. So basically, you are integrating cosine of u inside with respect to variable u. And of course, by formula, the antiderivative of cosine u is the same as sine u, right? So basically, that's the end to this problem. And the answer, of course, at the end, we have to change u back to x based on the formula at the top. So the answer is 1 over 3 times sine of 3x plus constant c, right? And that's the final answer to this problem. So let's look at the second problem. It is actually similar to the first one. We can let u be minus 6x. And let's see why it is helpful. Because we can find the derivative in the second step. It becomes du equals minus 6. And minus 6 is the derivative of minus 6x times 6. And let's see how we can use that. And the second line on the left-hand side is that I can write it as e to the power u. And same thing here. We have to change the x to something in du based on the second line in the green box. And I think the x, by using the whole equation here, the x is the same as du over minus 6. So I can put it up here. It's du divided by minus 6. And once again, the constant minus 1 over 6 can be pulled to the front. And we are integrating e to the power u with respect to variable u, which is unchanged after integration. So basically, our final answer is that it is minus 1 over 6 to the function e to the power minus 6 plus c. Let's do the integral for the function cosine x over 1 plus sine x. This one is slightly more difficult, and it would be quite difficult for you to make a good guess what function you can guess such that the derivative of it would be exactly the same as cosine x over 1 plus sine x. It's a hard guess. It's a hard guess. So let's drop this problem. I mean, and we don't have any power rule or other rules to help us to find this answer. And let's rely on the substitution method. Sometimes you have to try your luck. Sometimes I would like to try u equals 1 plus sine x as our substitution. Let's see whether it works or not. And the next step is to find the derivative. du equals derivative of this times dx. And the derivative of 1 plus sine x is cosine x, right? And let's keep it here. Let's see whether it helps or not. You see the bottom, the denominator is u, the bottom. And how about the remaining? The remaining is cosine x times dx. You see, it's cosine x times dx. And we kind of get a good luck now because cosine x times dx is the remaining term here. We need to transform the whole thing into something in u, right? So cosine x times dx, surprisingly and fortunately, is exactly the same as du. It is very lucky for us, and which means now we just need to integrate 1 over u, which is ln u plus c. It's essentially the end of the problem, but you need to change u back to what you have as a function of x on the right hand side. So which means the answer is ln 1 plus sine x inside the bracket plus the constant c, right? And let's do other problems. Please look at the current problem here. It is quite difficult for all of us to deal with the integral of such a big fractions, and we can try our luck. Why not? If I let u be 3 times x to the power 4 plus 7, at least I can simplify the denominator at least. Now the denominator is u squared, and the remaining terms is x cubed times dx. You need to convert it to something in u, and usually to convert it perfectly to something in u, we need to rely on the second line. The second line is that du equals the derivative of this, which is 12x cubed times dx. And let's see how to convert this part. Please use the second line here. The fact is that by using this, x cubed times dx is exactly the same as this, which means x cubed times dx is the same as u divided by 12, right? The 12 is like pulled to the left hand side. Then we get this equation. Now, after this substitution part, let's write everything in u. The bottom is u, right? And how about the top? The remaining term at the top, as I said, is gonna be by the purple star, it's gonna be du over 12. And once again, the 1 over 12 as a constant, I can pull it out. And I trust that you are able to do this calculation because the function inside is gonna be u to the power minus 2. And we can apply a power rule to resolve this problem. And it's basically finished, but we can write it in a slightly better way. I can write it as minus 1 over 12 to the function which is 1 over u, because 1 over u is u to the power minus 1. And u, please look at the first line, u is actually 3 times x to the power 4 plus 7. And that's basically the final part of our answer to this problem. And next, please look at the current problem here. Once again, it doesn't look something very easy because you have a product of two functions, and we don't have an easy formula for us to deal with the product of two functions when we do the integration, right? And sometimes we have to try our luck, as I emphasized. Maybe we can simplify it by using a u substitution. Maybe we can try this. We have to try. Sometimes it works, sometimes it doesn't, but I believe this one works. Let's see. The second line is so important. It helps us to simplify the whole integral if it works. So du equals the derivative of this is 3x squared times dx, right? And let's see whether the u substitution is successful. Usually, a u substitution would be called successful if you change everything inside the x integral to something in u, and you notice that you are able to do the u integration on your own. Then we call the u substitution effective. And let's try. Now, to turn everything to u, the term in the square root becomes u, right? Square root of u. And how about the remaining term? The remaining term, you have to turn it to something in u. And surprisingly, it works out perfectly again in this case. So we get the luck because you see x squared times dx is exactly what you have around here, which are the remaining terms you have not turned to u. And it means what? It means x squared times dx equals du over 3. And it means that I can write the x squared times dx as du over 3 here. And once again, I pull out the constant 1 over 3 to the front. You are integrating square roots of u. And you are able to do it by power rule because square root of u is the same as u to the power half, right? And by power rule, we can finish this calculation. So if you're able to arrive at this step, it's actually very good already. I'm just applying the power rule to the function u to the power half. And of course, at the final step, we have to change the u back to the function of x. And u is the same as x cubed plus 2, right? So I put it into as a replacement for the u term. And we have to add c at the end, and it's the final answer to this problem. So let's turn our attention to this current problem. X times square root of 2 plus x. We need to find integral of this. And once again, similar to the last one, we have to try something by u substitution. For example, if you let u be 2 plus x, and du is gonna be the same as something times dx, and this something is the derivative of 2 plus x, which is 1. So basically, it just means du equals dx, right? And please recall the current problem. The current problem is the top line here, and you need to turn everything into u. And if you notice that you're able to do this calculation quick, it means your u substitution would be correct. So let's do it together. Now we have a square root term, but the remaining term is slightly different. You see the remaining term is what? Is x times dx, right? However, it cannot be turned easily into something in du because du is exactly the same as dx, which means this one is du. So I hope you get my point. So we have the du term for the last term because du is the same as dx here. So we are left with one term which is called x, and you need to convert it to something in u also. And in that case, if the second line does not help, we can go back to the first line. The first line is what? The first line is x equals u minus 2. And u minus 2, I can put it here because u minus 2 is the same as x, right? And it means that you're asked to integrate something like square roots of u times open bracket u minus 2 close bracket with respect to variable u. And let's see whether you can do this calculation. I think we can distribute the square root of u inside. So the first term would be u to the power 3 over 2. The second term would be minus 2 times square root of u, which is u power half, right? And I trust that you're able to do this integration by the power rule. So for the first term, it becomes u to the power 5 over 2 divided by 5 over 2. The next term, if I use the power rule again, it's going to be the power is increased by 1 from 1 over 2, which is 3 over 2. And you have to divide it by the same factor, like this. And it means the answer is 2 over 5 times u to the power 5 over 2 minus 2 over 3 times u to the power 3 over 2 plus c. And please recall from the beginning that u is actually the same as x plus 2, right? So I can write our answer here. So it's basically the final answer to this problem.